Hi everyone, welcome to the lecture number 9 of unit number 1 matrices. In this lecture, we'll start discussion on homogeneous system of equations. So far, we have covered the system of non-homogeneous linear equations. Okay, so let us start the discussion on the homogeneous system of linear equations. In the consistency of system of linear equations, we have already discussed about the consistency of homogeneous system of equation. We have this form of homogeneous system in matrix form: Ax equal to 0, right hand side will be 0, means the column matrix B will be equal to 0. Okay, one more thing about the homogeneous system we have discussed already: homogeneous system is always consistent, means they always possesses some solution. As the reason is rank of A and rank of A comma 0, instead of B we are having 0 matrix here, means we are adding 0 column to a matrix. So when you add 0 column or 0 row to any matrix, the rank of the matrix remains unchanged. Means you will get the rank of the A is same as rank of A comma 0. And as these two ranks, rank of matrix and its augmented matrix A comma B remains same, because of that reason the homogeneous system remains consistent always. Means you don't have to check the consistency of homogeneous system, you just need to determine the solution of a homogeneous system of linear equations. Now nature of solutions can be in two forms, means the homogeneous system may have two types of solutions like non-homogeneous systems. That depends upon the rank and the number of unknowns. So when you are going to compare your rank of that matrix A with number of unknowns n, then the system, if they comes equal, then the system will have unique and trivial solution. The meaning of the word trivial is zero solution. Okay, means it will have unique solution, means all the unknowns will have single value and that value of every variable will be equal to trivial, that is 0. In that case you simply write all the unknowns equal to 0 when you get the rank of that matrix equal to the number of unknowns. It is very easy, just you need to understand the meaning of the word trivial. What do you mean by trivial? And it is a unique solution in the case when the rank is equal to, in the case 1, when the rank is equal to number of unknowns. Now if this rank is less than the number of unknowns, in that case the system will have non-trivial solution, that is non-zero solutions. Okay, and they are infinite in number, means the meaning of the non-trivial solution means it is infinite solution. Okay, for the homogeneous system. So whenever homogeneous system will have the rank of the matrix, coefficient matrix less than the number of unknowns, it will have a non-trivial solution, that is infinitely many solutions. So either it will have a unique solution or infinitely many solution, that depends upon the rank of the matrix and the number of unknowns. Now for determining these infinitely many solutions, in this case we set n minus r unknowns can be assigned arbitrary values, that is parameters. So whatever difference you'll get here, difference between the number of unknowns and the rank. Suppose you are having rank 4 and your unknown rank is 2 and the number of unknowns is 4. So the difference will be 4 minus 2, that is 2. So out of 4 unknowns, 2 unknowns can be assigned any arbitrary values, that is you can assign them some parameters like s, t. In the examples of non-homogeneous system also we have assigned parameters in example to one variable z, that is t. So in that way you are going to assign the parameters, and how many unknowns to be assigned parameter, that depend upon this difference, the difference between the number of unknowns and the rank of that matrix. Now let us do some examples on homogeneous system. Two examples I have solved for you. Okay, and there are few examples of this type I am going to leave for practice. So these are the two. Clearly you can see that these are the homogeneous system because the right hand side of every equation is 0. It is not non-zero. All the right hand side means every constant is 0, therefore it is a homogeneous system. So whenever you have a homogeneous system, you don't have to check consistency, directly you have to solve that system. Okay, so again for solving this system we are going to proceed like homogeneous system case only, non-homogeneous system case only, means we are going to consider the augmented matrix and we are going to repeat the similar calculations. Very first, the matrix form we are going to write of the homogeneous system. The matrix form is Ax equal to 0, where A is the coefficient matrix of the system, X is the matrix of unknowns. For the first system, the unknowns are x1, x2, x3 instead of x, y, z. Okay, so that I have listed, and the 0 means 0 matrix of order 3 by 1. Next, consider now augmented matrix A with 0. In the case of homogeneous, this B is 0 matrix, therefore 0 will have, means 0 column will add. So whenever we are going to perform transformation, this 0 column will remain same throughout the calculations, because we are having 0 here and we are going to perform elementary row transformations. So none of the entry will change. You use any transformation, these zeros will remain unchanged. Okay. Now for reducing it to row echelon form, the next thing is we reduce it to row echelon form. So starting for first entry, here 1 is available, right? So we can bring this one here for making calculations easier. So what I have done, the first transformation R12, I have changed the first and second row. After that, the next task is, this is the first pivot I have considered. Okay, below this pivot entry of the first row, I am going to make the entries below that entry 0. Means this entry and this entry I have to make 0 for getting row echelon form. So after applying R2 minus, I am going to change R2 and R3, R2 minus 4 times R1 and R3 minus 3 times R1. So after performing these two transformations, I will get this matrix. First row remain as it is, second row will become 0 minus 950, third row will be 0 minus 580. You can verify these calculations. Okay, now apply. What next? This is the first pivot. I will make the entries below this pivot 0. Now second row's pivot entries at this place. Okay, below this entry we have to bring 0. So for getting 0 here, we need to subtract from R3. R3 here we have 5 minus 5. So here we must have minus 5. So for that purpose, we'll divide this by 5 by 9. So 9 will get cancelled, 5 will remain. So minus 5 will become minus 5 minus 5 will become minus 5 minus minus 5 will become 0. Okay, so that therefore we are going to multiply second row by 5 by 9, and we are doing subtraction of third and second row. After doing that, we'll get this form: 1 2 minus 1 0. First row remain as it is, second row remain as it is, 0 0, here also 0, and here we'll have 8 minus 5 by 9. This is 5 already here. 5 into 5, 25 by 9 we'll have. So 8 minus 25 by 9 is some non-zero number. Okay, even if you keep it as it is, no problem. We need rank only. So after this is the final echelon form. This is the first pivot, second pivot, third pivot, and it is in echelon form. Okay, right? So as this is echelon form, you can see that these two ranks are always equal for homogeneous system, and it is the rank is equal to 3 because all the 3 rows are non-zero. In echelon form, we calculate the number of non-zero rows to determine the rank. So it is 3, and that is equal to the number of unknowns of the system. Number of unknowns are x1, x2, x3. They are also 3 in number, and the rank is also 3. It means the given system will have unique solution. And in the case of homogeneous system, whenever we have unique solution, that unique solution is a trivial solution. Trivial solution means zero solution. So the values of x unknowns will be x1, x2, x3 will be 0 0 0. Directly you can write x as 0 0 0. So whenever you get the rank equal to number of unknowns, directly write the solution as trivial solution. That is the unique trivial solution. Now let us do the second example. The matrix form of the second example is A equal to 7 1 minus 2 1 5 minus. There are total 4 equations are there in the second example, and that 4 equations will give us a 4 by 3 matrix. Unknowns are 3 x y z, and the right hand side matrix is also 0 0 0 4 by 1 order, because we have total 4 equations. Okay, now again consider the augmented matrix. Now here 1 is available, so I will do the first interchange of first and second row, get 1 here. Okay, so whenever we get 1 here, the calculations of means other transformations become easier. Okay, so if it is possible to bring 1, then only we take, otherwise directly you can do the transformation, doesn't matter. Now for making these 3 entries 0, this is the first pivot of this matrix. Now below this there are 3 entries that we have to make 0, so 3 transformations will perform simultaneously: R2 minus 7 times R1, R3 minus 3 times R1, R4 minus 2 times R1. Okay, and that will give us the matrix. I have done the calculations, you can verify them. 1 5 minus 4 0, 0 minus 34 26 0, 0 minus 17 13 0, 0 minus 17 30. This is also minus 17 and 30. So these two rows are equal, and this row is multiple of this row. Okay, now what I am going to do, if I divide this second row, if I multiply 1 by 2, I will get the same numbers, minus 17 and 30. So that I have done extra. I have multiplied second row by 1 by 2, so I obtained minus 17 30. So all these entries are same. Now this is the second pivot. Now this is first pivot. Below that I have made out the 0. Now below this I have to make 0. So by simple subtraction I can get there 0. So R3 minus R2 and R4 minus R2 I have performed. After that these last two rows becomes 0 totally. Okay, now this form of matrix I will get, and clearly this matrix is in echelon form. the 0 rows are appear at the bottom. The pivot of this row is to the right of the previous row's pivot, hence it is in row echelon form. Okay. Now, as this is row echelon form, calculate the rank. We know that for homogeneous system, rank of A equal to rank of A0, and it is equal to rank of A and A0 both equal to what? 2, and that is less than the number of unknowns. And the number of unknowns is 3. So whenever the rank is less than number of unknowns, the system will have infinitely many solutions. That is non-trivial. We can call it as non-trivial solution or infinitely many solutions. Okay. Now, whenever we have infinitely many solutions, we determine this difference. The difference of n minus r. N is the number of unknowns, r is the rank. So the difference here is 3 minus 2 is 1. So one variable one unknown we can assign a parameter. That is, one variable is free variable, you can say. Free variable means only out of 3 unknowns x, y, z, to any one we can assign a parameter t. Okay, new parameter. So before that I have written the equations again from the echelon form. Okay, so whenever we want to obtain the solutions, we rewrite the equations from this echelon form. After rewriting the equations, first row will give us x plus 5y minus 4z equal to 0. Second row will give us minus 17y plus 13z equal to 0. So only two equations we are left with. Okay, now out of these three unknowns, one unknown we are free to set. Okay, we can assign any one parameter to any one of the variable. So always prefer the last variable. So put last variable z as t, where t is any real number. Okay, so if you put z equal to t in this equation, you'll get the value of y as 13 by 17t. And if you put these two values of y and z in equation 1, we'll get the value of x as 40 minus 5 times 13 by 17t. After simplification, that will be equal to 68t minus 45t by 17 equal to 23t by 17. So I have obtained all the values of x, y, z. That is, x is 23 by 17t, y is 13 by 17t, and z is t, where t belongs to r. So t is real number, any real number. There are infinitely many real numbers. If you put different values of t, you'll get different values of this capital X. This will get infinitely many solutions in this case, in that way. Okay. Now a few examples of practice I am leaving for you. These 4 system of linear equations you try to solve. All of them are homogeneous system. Try to get their solutions like the solution that we have just discussed. Okay, so homogeneous system are always consistent. This is very important point, and either they will have a trivial solution or non-trivial solution. Trivial solution means unique solution, and non-trivial solution means infinitely many solutions. That understanding you need to get here. Now these type of calculations again we are going to do in the unit number 2 also, in the topic linear dependence and independence. So these calculations are very important. Okay, now few more examples on homogeneous, that on homogeneous system which involves the arbitrary constant. Okay, in the system of linear equations, that examples based on arbitrary constants of homogeneous system that we are going to discuss in the coming lecture. So that's it from this lecture. Thank you.